In this video, we'll get started creating the plastic housing for our PCB. Hey everyone, this is Matt with Learn Everything About Design, and in this video, we're going to get started creating the housing for our plastic design. But I think it's important to note that there are several different paths that you could take with plastic part design. So a couple things that you have to consider. If you're just trying to 3D print a housing for your plastic part design, then the shape is going to be determined by the restrictions of your machine. So when I've printed housings for things like Arduino projects, generally what I do is I make them fairly boxy so I can print them without support. I don't have to worry about having to clean up a bunch of support material. I just make something that's functional. That's not going to be the path that we're going here, even though the Hammond housing arguably could be done in the same manner. But some other ways that we could do this is we need to consider the electronics. Are they off the shelf components? Are we designing them? Is somebody else designing them? How is that going to affect our design process? So if you already have all the components, it makes your life a lot easier. You know where things are, where they need to be, and what your requirements and restrictions are. If the boards are being developed at the same time, that adds a layer of complexity that you unfortunately need to plan for in your design process. This means that if you're developing sketches, you need to design them in a way that they can be modified, they can be updated whenever needed. So, a third option, or another way that we can consider this, is if we are making something that is a consumer product or has a certain design aesthetic that we need to match. Now, in cases where I'm not sure what the outside really needs to look like, but there's some design direction, maybe it fits into a car or a certain product, it has to match, then generally what I do is I take the PCB, I would print it out on paper from the top, from the side, from the front and back, and then I would just get out pencil or pen and I would start sketching out what I want the housing to look like. This is a very important step in the concepting process. It's something that we're not going to be doing here because everybody's artistic level is different. And I don't think it's worth the time for us to explore that. But just note if you're doing this for your own projects and you have some components that you could move around or you're trying to create a certain design aesthetic, then printing them out on paper and just going at it with a pen or a pencil can be a very helpful exercise because it's a lot quicker and easier for you to do that than to try to do it in 3D. For our purposes, however, what I want to do is I want to explore it digitally. So we already know that we can get an off-the-shelf housing. We use this as the basis for the PCB. So we know that we can buy this. It's like $2 to get one of these housings. It already has a lid that has zip tie straps on it, and we can seal it, we can epoxy it. We know that this will work. The downside to this is it doesn't have openings for the connectors. We'll have to modify it. And if anything moves around, if we add any components vertically, then unfortunately, it's just not going to work. As it is now, if we take a look at this box and the lid, and we take a look at a section view, we'll go ahead and go to Inspect, Section Analysis. If we take a look at this now, you'll actually see that it doesn't fit. So the Cutie Pie has the USB and the quick connector. This is very functional. It allows you to chain a bunch of different boards and sensors together. But based off of common standoff sizes that would hold this off of the board, you can see that it doesn't fit in this housing. So additional modifications would need to be made either to the standoffs themselves, get some lower profile standoffs that may or may not work with the additional memory, or we need to space the lid up. Something has to happen to make this work. But in our case, we can design our own housing that doesn't really have that consideration. So what I'm going to do is I'm going to hide the box and the lid, and I'm going to focus my attention on designing our own housing. So when we think about this, a couple things that I like to do. First, I like to start a new sketch. I'm not worried about the openings for the connectors at this phase, but I just want to start a new sketch. In this case, I'll be on the right plane. And I want to begin designing my part. You'll notice the center of my coordinate system is right at the center of the board. I want to start designing the shape of the part from this side. This can be a helpful exercise, and a couple things that I like to do to get started is one, I'm not going to worry so much about the bottom of the PCB. I know that I'm going to need to have some space down here for things like screw bosses, but we're not really concerned with it at this stage. If we show the original housing, you'll notice that the lid, let's bring the lid back as well. The screws went down from the lid, and there were very few threads that were in the bottom of the housing. Now, in reality, what we might want to do is go the other direction because we know that those screw holes were not holding down the PCB. If we make this portion of it relatively small and this portion thicker, then we have a lot more room for threads. It means that we can use our longer screws and we don't have to be so specific about only having a couple threads in the bottom. So picking the direction that you're going with the housing is important, and also picking the shape. So to get started, what I generally do is I'll start with a line. I'm going to go from the origin, I'm going to come down, and I'm going to go from the origin and go up. And what these are going to be is construction lines that I'm going to use to reference. So I'm going to hit escape. I'm going to turn both of these into construction. Again, X on the keyboard, or simply go over to your sketch palette. And now these are underdefined. Obviously, they can move up and down. Again, at this stage, I'm not too worried about the height. I'm just looking for shape. Another thing, because we are dealing with symmetry, I like to add some additional construction lines that I can use for things like tangency references. Note that this housing is not symmetric. So we've got more components over here with this little microcontroller, and we could drop the housing down over here. And because we have a USB-C connector right here, it actually would be pretty cool if we drop the housing down and over and around. So that would help us maintain the shape of the board and maintain the shape of all the components, but minimize how much actual physical volume or space that we were wasting. So to do this, I'm going to go to my line tool, and I can use this, come over to the right, down, over to the right, over, and then I'm going to come back over here. I'm going to hit escape, and I'm going to turn that into a horizontal line. Hit escape again to get off my constraints. So that's obviously a very boxy shape. There's no draft on it at all. But again, right now, we're in the concept phase. We're just kind of looking at the shape. We're seeing what this looks like, and we're leaving things underdefined so they can easily move. I'm going to use a line tool again, which is L on the keyboard. I'm going to come over. Remember, this is our quick connector. And I'm going to come straight down. And I'm going to come over to here, hit escape, turn that into horizontal. Also, it's important to note that if we right-click, then we'll have some of the constraints that apply to our current selection here. But I find that people have a little bit more trouble with the right-click menu, especially when you're learning. This is very easy for us to find. So right-clicking and using a contextual menu based on your selection sometimes can be a bit harder. But just note that it can be found either here or by right-clicking. You can see exactly what we have. So now this is the basic shape of our housing. It kind of looks like a car. Put some wheels on it here, and now we've made a little car. But that doesn't really look very appealing, right? So that doesn't look like a great solution. But remember, that shape is only for this section right here. We've got this connector, we've got this microcontroller. There are some BJTs, there are some transistors over here that we need to be mindful of. There are a couple components on the bottom. There is some chip resistors, and this is a voltage regulator to deal with the voltage coming in. But for the most part, this is the main area of concern. This is where the bulk of stuff is. This is a micro SD slot that could be added in the little proto area. So again, components are very small in those areas. It's really just this right here and these three right here that we need to worry about. So we could carry that shape completely over here. Again, completely a concept phase. But we could take that shape this way, we could bring it this way a little bit, and then we could sort of build it down. In reality, this PCB could be smaller, we could tighten things up, but that's kind of what we have to work with. Sometimes the shape will change, sometimes the components will change, but what we have to work with is what's in front of us right now, and we need to use that and sort of plan for it wisely. So before I get out of this sketch, let's think about ways in which we could just make this look better. We know that we don't have any draft at this point because, again, we're still doing concepts, but we could think about this entire top piece being an arc. When you're dealing with plastic parts, you want to avoid flat faces. Flat faces have the tendency to sort of go concave or convex when they start to cool and shrink. And we want to avoid that, and we want to give it some structure by adding curved faces. So it doesn't have to be in every direction, but some curvature is going to help. So while we're concepting, let's just go to our arc, a 3-point arc, and let's just go between these 2 points and just give it a little bit of shape. We can do the same thing here. I'm going to sort of give it the inverse. I'm going to go where it's tangent, go from here to here, give it some shape. We'll go from here to here, give it some shape. And again, these are by no means final. These are just concept. Now that we have some more space, we could start to manipulate this. You can see that we can pull this in a little bit. We can pull this side in till we get a little bit closer. We can pull this down and just begin making some adjustments. So you can see that this helps us sort of take a look at the shape. If we want to, we can take these straight lines, convert them to construction, which means that our profile is only going to be in the closed off areas. So if we take any of these lines and then we select our profile, that helps you visually see just a little bit better what we're looking at. So now we're kind of seeing that we have this very boxy shape, and it essentially looks like we melted it. Right? We're just kind of softening the lines up. Now this, again, is a complete exercise in the concepting phase. This is not going to dictate the final shape necessarily. It's just us playing around with our tools. So now we could try to do something like a fit point spline. I'm going to avoid the corner points because that's going to fix the spline there. But I am going to go to the middle of my arcs. I'll come to this one, find the middle, come to this one, come to this one, and then back here. Then hit escape. And then I'll turn one of these into construction. So that way the only profiles we have are those closed regions. So we make these construction. And now that's our shape. And again, what we can do is we can continue to play around with this. If we take a look at the spline and we right click, we can insert spline points. So I can add a few more around different places, hit escape, and then I can move these around and start to change the shape. Again, very much concept. We're not looking at the final shape. It's important to understand that. What we're doing is we're just seeing what these shapes will look like in reality. And all we're doing right now is looking at it from the side. Again, this is a lot quicker with pencil and paper, but if you don't have those tools at your disposal, what I mean is, if you don't have the artistic ability to sort of play around and visualize shapes, then this is kind of what you can do. Now, I don't really like the way that this is turning out. I think the boxy shape looked a bit better. So what I'm going to do is I'm going to delete that spline, and I'm going to go back to the boxy shape. I'm going to delete these arcs and just sort of work my way backwards. So I think this shape gave us sort of the best midpoint definition. And what I mean by that is that midpoint definition is really just encompassing all of the components inside. So this is going to give us the best use of space, and we can add a little bit of geometry to add detail later, but this is going to help us get the best use of our space. So I'm going to finish that first sketch, and I'm going to go to my surface tools. And the reason I want to use the surface tools is because I want to maintain an opening in the inside for right now. Ideally, when we create plastic parts, we're either creating it as a solid extrude and shelling it for that consistent wall thickness, or we're taking our surface and we're going to thicken it, again, for consistent wall thickness. So this is going to be the starting point. I want to extrude. I'm going to select that entire profile, and I'm going to bring it all the way back until it gets to the end of my board here. Again, that's going to cover most of those components. I'm going to do 2 sides. Then I'm going to pull this one until I get past that microcontroller. So again, this is our starting point. We're going to say OK. And now we need to figure out what to do on the end of the board here. We need to transition from something. So we need these sides to carry on, but the top can actually sort of come down a bit. So a way that we can make this happen is we can use extend, or we can use ruled surface. Now there are 2 differences here that we need to understand about these tools. There are a couple different options in each of them, but the main difference is that extend is going to take our current surface, and the extension is going to be part of it. When we use a ruled surface, that is going to do the same thing. However, that ruled version of it is going to be a new surface. So if we do tangent or a direction, this is an entirely new surface. So the reason that's important is I can bring this all the way out to my board. I can say, okay. And now I can delete the stuff I don't need if I want to. So you can see here, I can keep some of that, and then I can get rid of other portions of it. So this is a nice sort of concept tool, because then what we can do is we can sketch. We can use project, again, project include, and we can bring maybe this edge and this edge into our current sketch. And now we've got these references that we can maybe take an arc or a spline, and we can come down over here. We can do the same thing over here. And these allow us to trim the surrounding surfaces. And one thing that we want to do is we want to be mindful of things like the center, if these are concentric or not, or if there's a certain radius value here. And again, that's going to be important when we're talking about finishing a design. In the concept phase, I don't really care as much about it. So I'm not spending a bunch of time dimensioning sketches. I'm not spending a bunch of time making sure all the corner points look right. And I'm not spending a ton of time making sure that everything has draft on it, because I don't know what this thing needs to look like yet. I need to figure that out before I spend the time in doing all those little details. So now that I have these references, I'm going to trim. I'm going to use this as my trim tool and get rid of that upper piece there. Now with trim, the sketch isn't automatically consumed, meaning it's still visible. So I can right click and repeat the trim, use this as my trim tool, and now I'm going to get rid of that little piece there. And then I can go hide that. Now what I can do is I can create something like a sweep. So if we say sweep, we're going to use a guide rail, or we can do a guide surface. It kind of depends on your housing, but in this case, I'm going to do path and guide rail. I'm not going to chain my selection. I want to manually pick the profile because I want to only grab these three edges. The path will be one of these on the back, and the guide rail will be the other one. So you can see that I'm able to sweep that shape. And if we look at it from the side, you can see how it's sort of extending. If we change this to be full extent or perpendicular to path, it's going to stop once it gets to the end of that edge there. That's okay. We're going to say okay. And then we can use extend. We can pick the edges that we want to extend, carry them out, and then we can come back and we can trim. So we could make a sketch, we could make a plane, whatever we need to just trim that away. For me, what I'm going to do is sketch on the bottom. And then I already have a profile that I can use for a trim. So if I say trim, the trim tool, we have to be careful. I can use this, and then I can just select the end. Sometimes it gets a little tricky. You have to make sure that you rotate this around and you select a section that's not inside this box. And then we'll say, okay. And now we've trimmed it at the end. The board still fits. And now it just looks a little bit better than just an extruded box. So that's giving us a little bit of an idea of just a quick way that we can concept a shape. If we wanted to fill in the end here, we could use patch. Because we know this is planar, we need to turn off enable chaining because they're two solid or two surface bodies at this case. So then we just need to work our way around, and then we can patch that. Now you'll notice that it's not working. Now it's not working because we probably left a tiny edge here. There's probably a small overlap or a gap. You can see that gap right there. And the way that we can fix that quickly is by stitching these together. So if we select stitch, you can see that that edge is green. We'll stitch it to the rest of the housing. And once that's green, it'll automatically fill in and fix that corner for us. And now we can go to patch, and now we can enable chaining because this is all one face. And we're able to cover it off. We'll repeat on the other side. And now if we stitch all this stuff together, it's going to turn this into a solid body automatically. So if we go to inspect, we do a section analysis. You can see that we've got this solid body and all the components are inside. The solid body tapers off. And that was very quick and easy. So at this stage, we have a lot of work to do, right? If we were going to use this shape as our final, we need openings for connectors. We need to worry about adding a bit of curvature. But we could certainly use this as a final housing if we were going to spend the time to fully define all of our sketches. We wouldn't want to leave all this stuff underdefined because I can just come over and I can move these sketches around, and then I might get to a situation where things don't fit anymore. And this is why it's so important that we define sketches fully when we're ready. Now, I like this as a concept phase because it does allow us to move things around and play with the shape. I could bring back these curves and I can see what this thing looks like if I change the curvature of this upper edge, but leave the curvature of this bottom one, or if I bring this one up a bit more and I bring this one down. You can see it allows us to sort of play around with those and just see what they look like in 3D. Now, again, I am not going to use this as the final design, but I at least want to give you the information on how you could if you wanted to. So in the rest of this video, I'm going to go through a couple other tools that are going to be helpful to us if we wanted to carry on with this shape. Our final shape will not be like this at all, but I did want to cover that concept phase because it is important, especially if you don't know what the final looks like. It's very easy to follow along and go through the steps that I do, but in the end, you need to know what your design is going to look like. You can't just follow the same steps over and over, or you're just going to get a bunch of boxes. So what we want to do, if this was going to be our final design, we go to Modify, Draft, and we need to start adding draft to this. So my pull direction is going to be based off of the bottom, and here we're going to hold down the left mouse button. I'm going to scroll down until I find that XY. Then the faces I want to draft. So I need to draft all the faces on the side of this thing. Anything that is going to be included in that pull. And the draft angle, I'm going to start typing D because we created those user parameters, and add draft. Notice that it could not taper the requested surfaces. Now, if you have this problem because you created some curvature here, then go back and try to do just a single face. You can see here that it doesn't like it. If we try to do, say, a side face, it's perfectly fine with doing these side faces, but it doesn't like this one with the taper. So how do we deal with that? Well, there are a couple different ways that we can do this. We can try to use move, we can select faces, and we can try to rotate those faces. We need to set a pivot point or a rotation axis, and then we can try to rotate them. And you can see here what we can do is we can enter D for draft, and we can just rotate it 2 degrees. And the way that this works is it actually ends up rotating this face here. I'm going to manually drag this again so we can see. And you can see that it's rotating this out, and this is why draft had a problem with it. Another thing that we could do is create a sweep cut. So on the back side, we could draw a small line at 2 degrees, and then we could use it as a sweep cut to go through this whole thing. If we really wanted to use the draft tool, sometimes you can get away with changing the pull direction to be above the faces that are having problems. And if we try D for draft here, sometimes it will be able to get away with that. It's kind of a geometry basis. It doesn't necessarily work 100% of the time, but it's kind of dependent on the geometry that you're working with. So again, you would need to sort of play around with those tools based on the shape that you have. You would obviously want to round off corners. You want to make sure that you do those vertical corners first. And when you're doing fillets, one thing that you can do is you can use the plus icon to add additional fillets in here. So if there are areas where you want a 5mm fillet, somewhere you want a 10, you can add additional edges, and we can go all the way around here. And let's say that this is maybe 2mm. So I can do that all in the same dialog. I can hold down Control or Command, I think, if you're on a Mac, and you can see here that we can quickly and easily add those. Now, this does produce some problems. Like we wouldn't be able to add it in this corner where 2 fillets intersect. It would not like that. We'd have to come back and add another fillet feature in most of the cases. But, you know, this is a quick way for us to sort of get some additional shape out of this. And then we would want to probably add it to the bottom as well. You're probably going to have to be mindful of the value of that, but you can see here that that works okay. And the last thing that we would want to do is we would want to shell this. We would want to figure out how we could separate this. So this is kind of the cool thing is you can decide how you want to break up your designs. If you're 3D printing something, you might want to simply split it right down the middle and make like a clamshell. So we could use, let's say, shell. We want to shell the entire body. We're going to select the entire thing here. We're going to say 2mm, and we're going to allow it to shell. Now, it's potentially going to have problems because of our 2mm fillet, so we might need to go thinner in this case just because I'm not using actual numbers. And then we could try to do a split body. So bodies to split, splitting tool, I'm just going to use this plane. And now if we take a look, we can hide part of it. So if you were going to do this as a 3D print, you could potentially create some little guides inside and you can slide the entire PCB in and snap the housings together. For us, again, this is not our final shape, but these are just a couple different ways that we can do the concepting phase. What we're going to do from here in the next video is we're going to work on the actual housing, the actual injection molded, designed plastic part housing. So if you have any ideas, if you want to create some sketches or some drawings on how you think it should look, then I can try to incorporate some of those. But what I want to do is I'm going to focus more on some of the basics. We're going to add a little bit of curvature and maybe some details, but I want to do a video on the basics of a thin-walled plastic part, adding our lips, adding the screw bosses, adding all those details. But now at least we understand a little bit about the concepting phase. We can keep this geometry, we can keep the sketches if we want. It was only a reference, so I'm not going to be using any of those sketches or any of the solid body geometry for the rest of it. But just note that we have that available to us as sort of that first step in sort of figuring out what we want this thing to look like. If you have any questions on this concepting process or you want a little bit more insight on some of the different ways to get started, then please leave a comment or send me an email. As always, thanks for watching, and we'll see you in the next one.